And 6 months later, after the tubes had been placed on the east end, the new 48-inch line was installed. A pipe-laying barge was specially designed by KRT to complete the installation. At the same time the water line was being installed, a concrete crib was placed over the top of the tubes and a new pier built on either side of the crib. When this work was completed, the area behind the crib was backfilled and numerous utilities rebuilt.
All of the work we've just been talking about, the containment site, the east end preparatory work, the relocation and connection of the new 48-inch water line, and the construction of the cofferdam, all of that work had to be finished before we ever started dredging for the tunnel itself.
Dredging operations began in 1981. The excavation was done with a 27-inch hydraulic dredge, which works something like a vacuum cleaner. It's centrally operated from a control room, where a dredge captain controls the depth and width of the dredge. Once the dredge is in place, the captain lowers an extension arm, called a ladder, with a cutter head on it. When it reaches the bottom, the dredge uses a side-to-side motion to excavate the trench. The dredging operation wasn't easy, partly because of the hard clay on the bottom of the harbor. The deepest cut was 110 feet below water level. Not only that, the trench itself is 180 feet wide at the bottom and is on both a horizontal and vertical curve through most of its alignment. The material dug out is then pumped up through the ladder and out the rear of the dredge. From there, it travels 1.5 miles through a submerged pipeline to the containment site, which was then ready to be filled in. After the trench is dredged, the next step is to grade and prepare the trench so the tubes can be placed. For this critical operation, KRT designed a special screed barge.
This equipment has some very unique features. It's a very specialty piece of equipment. And one of the most important features is that it becomes a stable platform from which we can work. This is accomplished by the way the hull is designed. It has an upper and a lower flotation unit with an air void between the flotation tanks. Attached to the barge are 4 large counterweights which we lower to the bottom, and when we release the load from them, the barge begins to come up out of the water until the water level is right between the upper and lower tanks. At this point in time, the barge is virtually unaffected by any change in the tide or water level. And this gives us the stationary platform we need to accurately grade the foundation course.
The grading material used is gravel, distributed with a clamshell bucket. The gravel is dumped in a pattern, then the actual screed, a heavy plow-like beam, is pulled back and forth on rails, spreading the gravel out to a 2-foot level at a predetermined grade.
With this system, we're able to screed the foundation course to within plus or minus an inch of the desired grade.
And while all the harbor work was going on, the tubes themselves were being manufactured in Port Deposit, Maryland. This is the shipyard of Wiley Manufacturing on the Susquehanna River. Under the largest tube manufacturing contract ever awarded, Wiley launched a completed tube every 3.5 weeks. Fabrication begins with 6 steel panels welded together to form a half-shell panel. The panel is transferred to a serrated rolling table, where another half-shell panel is welded to the first one. The welded steel plate is wrapped around a specially designed reel, and the shaping of the module begins. The 70-ton single module is then mated to another, and the double module is transferred to the shipways. There, it is added to other double modules to complete a single tube. 160-ton dam plates are then attached to seal each end of the tube. The finished tube is then side-launched. It then begins a 12 to 16-hour journey down the Susquehanna River to Bethlehem Steel's Fort McHenry shipyard in Baltimore Harbor.
The tubes are then towed to this facility where we then place the concrete for the outfitting part of our work. Bethlehem Steel's Fort McHenry shipyard was by far the best site available. We placed somewhere in the vicinity of 375,000 cubic yards of concrete. We have a two-shift operation going on at this yard. Day shift is used for erecting and stripping forms, and all concrete is placed on the second shift. Additionally, we have 160 craft people employed at this site.
It is here, during outfitting, that a tube starts looking like an actual tunnel section. That happens by placing concrete to construct the tunnel interior and provide the ballast needed to put the tube on the harbor bottom. There were over 1,200 individual concrete pours made in the 32 tubes. A lot of engineering went into developing the concrete forms for this part of the work. Each of the major phases, haunches and roadway, sidewalls, and arch, required its own formwork. And the same formwork had to be used in all 32 tube sections. To help this operation along, KRT and the form company came up with a unique form design. Each part of the form had to be broken down into pieces. All the parts were handled by a special forklift and put in and taken out through 4 feet by 8 feet access holes in the top of the tube. In addition, they sit on self-propelled travelers which carry the forms through the tube for placement. The yard worked in 2 shifts. The day shift stripped, moved, and erected the formwork, and the second shift, at night, placed the concrete. With this system going, tubes were completed from outfitting in 13 weeks. With the outfitting completed, the tube is towed to the tunnel site by several large tugs. Then began the process of lowering the tube section to the harbor bottom. To do that, KRT designed this lay barge. The lay barge is a set of catamaran barges connected by a pair of girders. Inside the girders are 4 lowering falls attached to the tube. They're winch operated and connected to lifting lugs pre-placed on the tube at the outfitting yard. The first step is to position the tube between the hulls of the lay barge.
Once the tube is in the hulls, the ballasting of the tube continues until we've achieved somewhere between 500 and 600 tons of negative buoyancy. This enables us to have a tube that's heavy enough to place on the harbor bottom.
This is done by ballasting the tube with concrete. To get the concrete out to the lay barge, agitator barges are loaded from a local concrete plant about a mile away from the tunnel site, then moved to the lay barge. The 2 agitator units holding the concrete on each barge are capable of carrying 24 cubic yards of concrete. Once at the lay barge, the agitators are lifted hydraulically, filling the concrete buckets, which are then handled by the crane on the lay barge. The concrete is then deposited between the bores of the tube section. Additional concrete is then placed in the side pockets of the tube using the Tremie method to complete the ballasting. It's then ready to be lowered to the harbor bottom. The lay barge is moved into position above the tube's final location in the trench. It's anchored, and a temporary survey tower is mounted on the outboard end of the tube. Highly critical calculations are made by the engineering staff as exact measurements are transmitted from a position on land to the control room. The operation requires constant monitoring of the survey equipment for accurate alignment of the tube during placement. The tube is then lowered onto the screeded gravel foundation to within a few feet of the tube already in place. Once on the bottom, the 2 tubes are connected using railroad-type couplers. The couplers on the tube being lowered are extended by hydraulic jacks. Once coupled, the jacks are retracted, pulling the tubes together. That forms a seal between the rubber gaskets on the ends of the tube.
Then people on the interior of the tunnel open valves which allow the water between the bulkheads on the ends of the tube to drain out, and that action then creates a tremendous hydrostatic pressure on the end of the tube being placed, which forces the gaskets even tighter together and makes a permanent seal.
After each pair of tubes is joined together, they're locked into position with backfill material. The backfill is placed evenly outside and between the tubes using a specially designed barge outfitted with high-speed conveyors fed by a centrally located charging hopper.
Once several elements are placed, the tube interior work can start. Early on in the job, it was recognized that a significant amount of planning and engineering would be required.
An engineer was assigned to this phase of the project 6 months before the actual work began. Interior finishing involved installing liner plates in the area between the bulkheads. The 120 bulkheads were then taken out. The mechanical electrical ducts were extended through the joint between the tubes. Steel forms also had to be specially made to place the joint concrete. And concrete trucks, built specifically for this phase of the job, were lowered into the tube to place all the concrete inside the tubes. And concrete safety walks and patrol walks were built.
The schedule dictated that the 43,000 lineal feet of walkways be placed at approximately 1,200 lineal feet per week. The pre-engineering and planning proved invaluable in accomplishing the interior work.
8 tunnel elements were placed and backfilled on the west side of the harbor. Then work shifted to the east side. 16 tunnel elements were then put in place here, and eventually, as work proceeded from each shore, the 2 ends of the tunnel met in the middle. After that, the tunnel approaches, ventilation buildings, toll booths, and other finishing work would be done. But the construction of the tunnel alone was by itself an extraordinary achievement. Ray Gully.
I think the engineering and planning we've done have paid off very well, and I'd have to be very complimentary about the personnel that have worked on it. I think they have done a superb job, right from Martin Kelly on down, and I think it's a credit to all of them, and I think we got good advice from our partners, and as a consequence, on the whole, the job has gone very well.
For me, this has been a very gratifying project to work on from both the engineering and construction point of view. Often we were confronted with what seemed to be big problems and were able to turn them into small ones through thorough engineering and planning of the work. The development of our value engineering cost proposals for various aspects of the jobs reduced costs by some $8 million. All in all, everybody that worked on this project did an outstanding job.
KRT brought the project in on schedule and under budget. When the tunnel is finally open to traffic in 1985, some 60,000 vehicles a day will use this tunnel. And finally, for the city of Baltimore, the state of Maryland, and the nation, a critical gap in our interstate highway system will at last be closed.
Good evening, I'm Donna Hamilton.
And I'm Jeff Pilot. We'll talk to one of the most prolific songwriters of all time. We'll talk with Neil Sedaka.
We'll also take you to a school for cops and robbers and to a beefcake contest.
Evening Magazine's up next in the new Harbor Tunnel. Stay with. Happy Wednesday, everyone. Welcome to the show. Tonight, we got a great show for you. We're on the eastern end of the harbor. This is the Eastern Toll Facility.
Big.
That will serve the new Fort McHenry Tunnel. Opens November the 23rd.
So soon?
24 lanes here, Donna, for your toll-paying pleasure. I'm Jeff Pilot.
And I'm Donna Hamilton. They've been working on this thing Ever since I've been here.
About 5 years.
Yeah, a long time. Going to be open soon. They're also having a race through the tunnel on Sunday, October 6th,
right.
sponsored by the Heart Association.